Welcome to this session on Demystifying Containers. I am Kunal Babre. I am your presenter for today. I have been working in IT industry for over 15 years and I have worked in several roles in development, being systems analyst, product manager, application development manager, and currently work as a cloud solution architect at Microsoft. I am certified Kubernetes application developer and Azure architect. In this session, we will start with why and how containers work, then look at why we need containers, orchestrators, and where Kubernetes fit in. Finally, discuss options to run containers on Azure. Let's start with why. Gartner predicts that by 2022, more than 75% of global organizations will be running containerized applications in production. Just because Gartner says it does not mean we should do it. Not all their predictions turn true. So, why should we consider containerization? For that, we should look at what's happening in cloud front. Several organizations have already embarked on the journey to cloud. And for most, lift and shift, that is VM or virtual machines on prem to virtual machine in cloud, has been an easy entry in the cloud data center. While being in cloud itself is a big win in terms of scalability, efficiency, the next logical step, cloud optimize, is to explore options to improve productivity and reduce costs. This is where we start looking into cloud maturity. Lift and shift, least effort for quick migrations, usually infrastructure as service, IaaS is what we call them, easy entry into cloud data center. You know, cloud optimized, it's about increasing density and lowering deployment cost. That helps you improve productivity and DevOps agility. Containers are great fit here. And finally, app modernizations, where you're looking at re-architecting applications by modifying code or rewriting them completely to utilize, SaaS or PaaS services. This eliminates overhead of managing and maintaining operating systems, database platforms, and optimizes applications for long-term agility, scale, and high availability. Here is a nice chart that you can use to speak to business to get support for cloud optimized initiatives. Your ROI, return on investment, improves as you move top right. Some customers have seen overall savings of up to 56% by adopting a mixed model. Okay, now let's look at containers from technical perspective. Containers get their name from shipping industry, where the problem was I have all these different things I want to ship and all these different ways of shipping it. How do we create a universal way to ship anything by any method? So the industry created a shipping container. It's a known size and shape. You can put whatever you like in it, and every shipping method is designed to handle this container. A really smart person stole this idea and introduced it to us techies as container. Pun totally intended there. The idea is really simple. You construct a deployable unit called container with all your code dependencies and place your application inside it. Now you can run this application on my machines, Joe Blogg's machines, and someone else's machine too. So let's compare it with virtual machines. Fundamental goals of virtual machines are different to that of containers. Virtual machines fully emulate foreign environments. while containers focus on making applications portable and self contained. Here are some of the advantages of this approach that containers provide. They share resources with host OS. It makes them order of magnitude more efficient. Example, starting and stopping times are fractions of seconds. Also, it reduces the overhead. Portability of containers eliminate whole class of bugs by subtle changes of environment, or commonly known as works on my machine. Lightweight nature of containers means developers can run dozens of them at the same time on a single machine. When you think of containers, think of three things. First concept is of runtime isolation. It provides you a sandbox environment for your application. It is achieved using two concepts: namespace isolation, that provides the ability to isolate processes so it gets its own view of the world and generally can't modify or view another one. Then the control group or C groups provide the ability to partition resources such as compute and memory so that the containers cannot monopolize a machine's resource. The second concept is image. It is very simple binary representation, same as how we have images for our virtual machines. Image is built using layering capabilities. You build on top of parent image. Example, uh, the WordPress image here is built on top of Nginx image. It's a simple web server, right? And if you want to compare images, if you are a developer and want to compare images, think of an image as a class or a blueprint, and container as an instance of a class, that is object. Finally, container engines that are responsible for taking a container image and turning it into a container, that is running process. There are also several competing container engines like Docker, Rocket, Containerd, etc. Most of these container image engines today adhere to a standard image format based on something called Container Initiative, OCI, that originally came from Docker version 2 or was based on Docker version 2 image format. So let's look at how you can define image for Docker with Docker file. Think of it as a set of instructions that Docker uses to automatically build the image. Here is an example of a Docker file that can be used to run a Contoso app. The start of the Docker file is from, that is a parent image this Docker file is inheriting from. And every line of Docker file is defining a layer in your container. The next one here is a work directory. It's an instruction set that sets the working directory for the instructions that follows it in the Docker file. The next one is a copy instruction that copies the new files or directories from a source and adds them to the file system of the container at the path destination. The expose instruction does not actually publish the port. It functions as a type of documentation. So this container exposes port 80. That's a kind of a documentation. And finally, the entry point allows you to configure a container that will run as executable. So in this example, we have taken this Contoso app, which is a ASP.NET app, and defined a Docker file for it. Once you have written Docker file, there are a bunch of Docker commands to learn that broadly fall in these three categories. Build, how do I build image for Docker file, from Docker file, right? Run, how do I run Docker containers while using the image? Share, how do I share it with others / publish it, right? So now let's look at the quick demo In this demo, we will run a simple container image called Nginx, a Linux based popular web server. Let's quickly bring the console. So I am in my PowerShell console, right? I'm just going to do a few commands. So I would say docker container run, or you could just use docker run more commonly. Docker run, name, let's call it web. We're going to do /d for detached. Does not keep the console attached to the container while it's running. So I'm going to say detached. I want to expose ports or publish ports. Let's do it 8080 on my machine to the port 80 that this container is running. And then I want to do Nginx, and the tag is latest, so I'm going to use the latest version of Nginx. Within a few seconds, the container is now running. So now if I go to my browser, right, and if I go to the app, and if I was to refresh this, I would see we got Nginx server running. Finally, if we want to stop this, then we can do docker rm -f, so remove force, -f is for force, and then web, and that should stop my container. So if I go back here and if I was to refresh, we should say it's we can say it's struggling, it's not able to load that. Yep. Excellent. So let's move back to the slide. The next concept in this path is you want to know about container registry. And the simplest way to explain container registry is it's a common place for you and your team to manage container images. Like with any share, it can be private or public, right? There are several providers that help you host them. Example, Docker has something called Docker Hub, which allows you to do both public and private images. And more commonly, example would be a private cloud providers would have their own registry. So for example, Azure has Azure Container Registry. Key thing to remember is you need to ensure this images are secure and highly available. Okay, so now let's look at a bit more deeper example. What we will do in this example is we'll create an application, an MVC application from scratch. Then we will Dockerize it. Then what we'll do is we'll use something called multi-stage build. So we'll define how the .NET application is built within the Docker file. Then we'll build it and we'll publish it to Docker Hub. So in this example, I have created a repository called Kunal Babre /demo, and we'll publish this with a tag latest on the Docker Hub. So just to show you that, if I go back to my Docker Hub, I have created an account and I have created this repository called Kunal Babre. So it's my handle, and then /demo is the name of the repository. So if I go back, we'll do that, and then we will basically start the application and see how it works. And then if time permits, we can also push that into Docker Hub. So let's get started. So I'll go back to my console, right? Let's see. Okay, cd demo docker file. And then let's do the new MVC. So we're going to create a new application, MVC application. Right. So now this is created. We can do code dot. So I'm just going to bring up Visual Studio Code. So as we can see, this is just a plain vanilla .NET Core application. All I'm going to do here is I'm going to actually say, hey, I want to create a Docker file. So create a new file, and the special name for it is Docker file. So D capital Docker file, and then it recognizes it's a special file called Docker file, right? Now I'll start defining how this file, the environment in this file. So let's start by, let me see. Okay, so let's start by saying, hey, code, I'm going to bring up my code editor for a minute. Okay, so that I can copy the file that I already have written, and I will walk you through this, right? So here I'm specifying I'm going to start from the base image, which is a SDK, because I want to build this, right? So I want to use a full SDK version. Set the working directory to /app, then copy the CS project file into that folder /app. Then I'm going to run .NET restore, so that should go and restore any of the NuGet packages. Then copy everything else, and then finally execute .NET publish. That's going to publish and create the artifacts in the out folder. Now that's my first build part done. Then I'm defining, hey, now create a new image based on the runtime. So this is not having that SDKs. Again, set the same /app folder, and then copy everything you did on the previous step, from build. So this is a build /app/out. So this is where I was putting those artifacts into the current folder, and then I need to provide entry point. So this is a standard .NET command. So I'm going to say, hey, run .NET and the name of the DLL. So in this case, the DLL name would be, let's have a look. I think it was Docker Fun, because that's the name of the project. So Docker Fun .dll. Once this is done, I should be able to execute command docker build. So let's do terminal docker build, right? So we want to docker build, and we want to specify tag for this. So I would say -t Kunal Babre /demo. So this is a tag I'm applying. This is the name of that image, and then I'm applying is latest, and then I'm going to specify a dot. That means in the current folder. So you can find a Docker file in the current folder, and that should go and build it. So we can see it's going and fetching that image, running all those commands, and then building. Just take a few minutes and it should be done. Okay, so now it's successfully done it. Now let's try and run this. So Docker, let's call it, I'm going to run it. So Docker run, right? Here I would specify again, name is web, like we did before. Detached, if you remember, -p publish. I want to publish port 8080. I know there's site running on port 80 in the container, and then the name of the container or the image is latest. So that has successfully started our container. So if I go back to the website and let's refresh this page, and we can see our site is running. Okay, so now that I have done this, if I want to stop it again, I can go back and do docker rm is remove minus force web. I'm using this name web. If you haven't given the name, you can use the hash. So few digits or few characters from the hash is fine so far as they are unique. So in this case, I can just say b5fe, for example, and that should be fine, right? So that should stop my image. So that's one part. I have built the image and I have stored it locally on my machine. So if I look at docker image ls, there's several images that are on my machine, but if I go up, I think it should be somewhere on the top. You can see Kunal Babre demo, and then it was built a minute ago, right? And size of it is 210 MB. Okay, so now let's look at publishing it. So you can do docker push, right? And the command there would be docker push and what this will do is this will push my image into that public repository I just created, right? So this is going to just go and verify. It's quite clever the way it does it. So it will only push the differences, so not every layer is pushed. The base image, for example, already exists, so it will only push the differences. Okay, so just give it a minute and then we should see it completely pushed. Almost there, almost there. Okay, so once it's pushed, and I think it's almost getting there, but let's have a quick look here. So once it's pushed, what we should see is, when it was published. So if I was to refresh this, once it's done, we should see that coming here soon. So I'm going to just quickly check. Yep, it's done. So now we should see the date refreshed here. Few seconds ago, right? Okay, so moving on from there, let's look at another interesting topic: container orchestrators. Managing multiple containers is not fun. It turns out that packaging and distributing is just a small part of managing applications at scale. We need to know that our containers are up and running, restart automatically if failed, able to scale them from one to hundreds of them, right? We need to be able to access containers when they come online. We need containers to be able to talk to each other. We are building microservices very commonly using containers technology, or even simple as web front, web application talking to your API server. We need to be able to have that communication. We need a safe and secure environment to handle sensitive data and much more. So this is where the container orchestrators come in. They provide things like isolation, so they keep containers from interfering with each other. Scheduling, right? Where should my container run? You might have hundreds of virtual machines. Which machine is fit for running these containers that needs a GPU, for example? Discovery, where is my container, right? How do I access it? who provides the DNS, who manages the DNS. Scale up, right? Scale up from one container to hundreds of containers. Suddenly there was a spike on my shopping website, and I just want to quickly scale them up. Monitoring what's happening with my containers, and this is where the container orchestrators come into picture. They address challenges of running multiple containers across, and there are several orchestrators out there. There's Kubernetes, there was a Docker Swarm, or there is a Docker Swarm, and many others. However, Kubernetes is one of the best open source container orchestrators. It's designed to automate deployments, scaling, and management of applications. Kubernetes is portable, extensible, open source platform for managing containerized workloads. It has some great features and capabilities. Self healing. If a container or host machine crashes, it can automatically spin up new ones without you having to do anything. Extensible. Modular makes it easy to extend. That's exactly what Azure and other cloud providers do. When running an Azure, you can ask for disks and it knows it will provide Azure disks or Azure managed disk or file shares. Portable. This truly enables you to run anywhere, whether it's on premise, in cloud, on edge devices, people run it on Raspberry Pis, etc. Let's quickly look into a high level architecture. When you deploy Kubernetes, you get cluster. A cluster consists of set of worker machines called nodes that run containerized applications. Each cluster has at least one worker node. The control plane is the brain that makes the global decisions about the cluster, as well as detecting and responding to cluster events. For example, if you or if one of the nodes stops working, right, or crashes for some reason, it automatically starts containers on a new node. Managing clusters and ensuring control plane and nodes are healthy can be time consuming and error prone. This is where most cloud vendors provide managed clusters. Example, Azure provides Azure Kubernetes service. Azure provides you with rich set of services to simplify the deployment and management of container-based workload. Let's look at some commonly used services to host containers. You can simplify the deployment management and operations of Kubernetes with Azure Kubernetes service. Or if you don't want an overhead of managing clusters, you can run them on, you can run your containers on a platform as a service or serverless platform, both using Azure App Service or Azure Container Instances. You can run fully managed OpenShift cluster that is jointly operated with Red Hat, or you can bring in your own partner solution that runs great on Azure. Or if you got batch, kind of jobs, cloud scale jobs, scheduling and compute management requirements, you could look into Azure Batch. Of course, anything else you can always run things on virtual machines. So let's have a look at a quick demo, and this is a pre-recorded demo where I would show you how you can run a Super Mario Docker image in Azure. So here I'm searching for the Super Mario. This is a nice image somebody has built. So let's grab the latest tag. I'm just going to take the latest tag, right? Make a note of it. Now let's look at the details of this image. I think they run the application at different ports. So let's just check what port they run it at. So as we can see, it runs it on 8080 port locally. So it's running on port 8080. Now let's go and deploy a Kubernetes or Azure container instance. So we'll go and create a Azure container instance. And this is where we will just create a quick deployment. So we choose a right subscription, a resource group to deploy it, and then I will name it Super Mario. Yeah, has to be unique, so UK West is fine. It's a Docker hub image, and we'll just paste that image name with the tag. If we don't specify tag, it's okay. It always goes for latest. It's a Linux machine, that's fine. We remember the port we want to expose, so it's going to be port 8080. And I think we are good here. I'm not providing DNS label, that's fine. And I think we should be good. And now it will start creating that container instance. It takes a couple of minutes, so I'm going to just quickly skip to the next. Yeah, and then we start. Once it's deployed, you should be able to access it. So we can access it using a public IP address. So if I open that and remember port 8080, so let's do that. And there you go. There's a Super Mario game here. And it does work. This brings us to the end of the session. Thank you so much for your attention and all the best.